Good morning, everyone. I am thrilled to welcome you all to today's webinar organized by Bhavanam C2C. It's wonderful to see such a fantastic turnout. I'm sure we are in for a highly informative section. Before dive into today's section, let me give you a small intro about the organizer of today's webinar is Bhavanam C2C. Bhavanam C2C is an ISO certified private limited company providing comprehensive consultancy to construction and corporate training services in the field of civil engineering. We are specialized in dealing with architectural, structural, and construction management courses. Our courses are delivered by IIT gold medalists and highly experienced industrial professionals. We are a team of skilled people striving for better students and working for a professional community in the civil world. We share our knowledge and industry experience with next generation civil engineers to build a strong foundation to their careers and to convert their dreams into reality. With a commitment to excellence, we have trained over 5,000 plus students, helping them achieving significant career milestones through our extensive training programs. Now, coming to today's section, today we are fortunate to have Mr. Ali Shamsur Rahman sir with us, who brings his exceptional experience with a background as a senior structural engineer. Mr. Ali Shamsur Rahman sir has been instrumental in shaping the knowledge and career of countless civil engineering professionals. This depth of experience and passion for teaching make them a valuable asset to our company and to everyone here today. Without any further delay, let me hand things over to Mr. Ali Shamsur Rahman sir to lead us into today's section. Thank you for joining us, and I hope you gain valuable insight from this webinar.
Let me introduce to first. I am Ali Shamsur Rahman. I am Ali Shamsur Rahman. I have a 20 years experience in the structural design and construction since 2003. Since 2003, I am working in this line. Okay, now I am going to present a wheel load calculation according to ASCE 716. Let me share my screen so that I can share my presentation. So today's our subject is ASC 716 in practice. Mainly, we discuss about just main wind resisting force resisting system load calculation, and there is several method of calculation, but we are focusing only directional procedure of MWFRS, or that means main wind force resisting system. Okay, let's introduce the ASC 716. You all already know that it is a international standard. Today's our key topics in this lecture, in this session, is introduction about wind load calculations, wind load parameters and definition, parameters, procedure and method of analysis, wind load calculation procedure, wind load on building, main wind resistance failure, directional procedure, and example, hands-on calculation on the how to calculate the wind loads and apply on structure. Introduction. What is wind load calculation? Why we use the wind load calculation in a structure? Wind is a significant force that must be considered in our design structure, and the building codes, the several building codes, that is IS code or ASCE or our national building code, international building code IBC, or in our country Bangladeshi building code BNBC, all has a standard guideline to calculate the wind loads so that uh, we can consider the wind force on the building. So the importance of the wind load calculation is the wind can exert a significant force on structure and affecting both their overall stability and integrity of individual elements. So incorporated wind load calculation can be lead to structural failure. If you not consider the wind load in our calculation, it may lead to structural failure, discomfort to occupants, or even a catastrophic collapse. So the building codes gives us a guide to calculate the wind loads and how to apply on the structure. Why why we calculate the wind load on it is because we calculate wind loads for structural safety, compliance with building codes, preventing the structural damage, economic consideration. We also, if we consider the wind loads, it gives us a economic by the decreasing the structure with appropriate wind loads resistance. We minimize the maintenance and repair cost due to the wind damage over time. So we have a economical perspective to consider the wind loads impact. So dynamic response of the wind and comfort. Why it is? Because wind can cause the structure, especially tall buildings and bridges, to sway. Wind load calculation are essential to control this movement, reducing the risk of the figure and ensure the occupant comfort. Impact of emergency efficiency. Wind process can influence how buildings respond to ventilation and insulation needs. Acute wind load calculation help to design the building envelopes that optimize energy consumption by managing air infiltration and temperature control. Now we are going to wind load parameters and definition. Before we going to calculate main topics, or we are discuss some definition about the wind load parameters and such as what is open building, what is enclosed building, what is directional capacity, what is basic wind speed, such like that. Okay, so let but first consider the what is enclosed building. In this context, ASCE 716, a building enclosed is defined as a structure that meets specific criteria for the protecting the interior from the external wind force. For the building to be classified as enclosed, the following condition: if building is enclosed, if it is the opening is less than if the opening is less than 1%, then it is enclosed building. Opening the building surface window do not exceed a certain threshold compared to the surface area of the walls or roofs. Ratio of the area of the opening in each wall of the building must be less than 4%. If it is a less than 4%, the building should be considered as a enclosed building. Okay. If let a building wall length has a higher length is 20 feet and height is 10 feet, that is 200 square feet. So if the opening is less than 8 square feet, then it is called a enclosed building. Area of the walls, or 4 square feet, which is less. It is called the enclosed building. Open building. If the open building is something like if the total opening is greater than 80% of the gross area, 80% of the gross area, then it is called the open building. That is called the open building. Okay, and what is partially open building? If the building is opening is greater than 4% and less than 80% of the total gross area, then it is called the partially open building. Here's some criteria for the partially enclosed building. The total area of the opening, if the area of opening in the wall that receives positive external pressure exceed 4 square meters or 1% of the total area of length, and additionally, percentage of building is balanced the building envelope not exceed 20%. So it is if it is greater than 1% of 4 square meter or less than of 20% of gross area and open area, the less than ratio is less than 20%. then it is called partial open building. What is low-rise building? A low-rise building is it can be enclosed or partially enclosed or open building. If the main roof height is less than 60 feet or 18 meters, then it is called the low-rise building, such as a three-storied building or single-story shed. This is the low-rise building, which is the less than the 60 feet of the in height or mean roof height. Okay. Permitted procedure how we calculate the wind load and how when the ASCE 706 has a specific guideline to calculate the wind loads as a structure. We can calculate two ways. One, we can consider the main wind force resisting system, or we can calculate by component and cladding. Okay, what is the main wind frame resisting system? It refers to the primary structural system responsible for the transferring wind loads from the building to the ground. Or it means if the structural member is capable to withstand, it is directly transfer the wind load from the main structure member to the ground. So it is we apply the wind load on the main structure, such as column, beams, etc. And component cladding, this refers to smaller elements such as door, windows, roof panels that are directly exposed to the wind. In this case, we consider the component cladding procedure. So in our case, we are considering the main structural resisting frame system, or that is, we apply the loads on the column directly to the column, beams, etc. Main structural resisting system. Okay. So method of analysis. According to the section 26.1.2.1, the wind loads for MWRF must be determined using the following procedure. We can use the only 3 2 or 4 procedures, mainly 3 procedures, but procedure 1 is divided into 2 parts, part 1 and part 2. And the procedure is directional procedure. It is discussed on chapter 27. It is further divided by 2 parts, parts 1 and part 2. We discuss only for part 1, envelope procedure and internal procedure. What is directional procedure? Directional procedure. A directional procedure applies to the building of all heights, provide the meet the specific criteria laid out in chapter 27. This method takes into account the wind direction and calculate wind pressure acting on the building based on the exposure geometry and height. Directional procedure is determining wind loads, building, and other structure to specify wind direction. That is, this procedure we can consider the specific wind direction is specified. It may be north south or east west or south north or west south. It is in this procedure we fix the direction of the wind. So we have to calculate each direction of the winds. So apply each direction of the winds. Okay, directional procedure also calculate wind loads based on the wind acting from particular direction, considering the variables such as wind speed, its exposure, height, and structural configuration of the building. It provides detailed pressure coefficient for the various phase of the roof or slopes or the building. Example. If I give an example, the method is commonly used. This method is commonly used for high-rise building or complex structure where wind direction and exposure significant impact the load distribution. For example, it is a skyscraper or in urban settings would be analyzed, or it can be used for any height of the structure from low-rise to high-rise building. Envelope procedure. Envelope procedure is basically used for the low-rise building. It is mainly used for the low-rise building that meets the requirement in chapter 28. Low-rise building are typically defined that we already said that if the building height is less than 30 feet, it is called low-rise building. 60 feet, sorry, 60 feet. It is called the low-rise building. In this case, we can use either directional procedure, or we can also use for the envelope procedure. Envelope procedure, okay, and it is directly described the this procedure used to building is made the specification criteria outlined in it is outlined in the chapter 28. So we now with directional procedure is also applied for the building structure, or this is another procedure that is applicable for the rooftop structure such as HBS system, or the signboard of the roof, fastener of the wall and signs, chimneys, tanks, open signs. It is the permitted. It is the directional procedure for building apparatus and other structure. It is discussed in chapter 29. It is overall discussed in chapter 29. Uh, Okay, wind tunnel procedure. It is the main procedure of the wind tunnel procedure is the vast and accurate procedure in the wind design, load calculations. The wind tunnel procedure is most detailed and precise method used for the both buildings and other structures of all types. It is required when other members are insufficient due to the complexity of the building structure, such as building in the unusual shapes or located areas of the significant variable. Winter, we discussed the previous directional method, directional procedures or envelope procedures. It's only we can apply if the structure is regular or height is regular shape, and then if no other complexities such as vertex or other. Okay, wind tunnel procedure. We are discussing about wind tunnel procedure. Wind tunnel procedure, a procedure for determining the wind loads on the buildings and other structure in which pressure or the force and the moments are determined for each wind direction considered from the model of the building or other structure and its surroundings in accordance to chapter 31. Chapter 31 was significantly discussed on the wind tunnel procedure, where application the wind tunnel procedure can be used for all type of buildings and other structure. Okay, when to use this procedure is typically employed for a building with unusual shape, complex geometry, large structure that require more precise analysis. It is also used building where the wind loads cannot be accurately determined using the simpler method such uh, as second or unique architecture forms. This method involves physical wind tunnel testing and computing fluid dynamics solution. That is, in this procedure, we made a model of the building, and we test how it reacts as when we apply wind on this model, and we get the data from this model and this and analyze this data. By analyzing data, we can calculate the what is the load applied on the structure. When design has irregular shape, we load calculation procedure. The velocity pressure, first we have to determine the velocity pressure. Velocity pressure QZ is at significant height Z. It is the building height from 0 to above. The ground is crucial calculation to accessing the wind load acting in the structure. This pressure is derived from the basic wind speed to and as several factors account for the structure exposure topography. Okay, the equation is if you use the imperial units, that is pound foot. This equation is QZ equal to 0.00256 kz. Kz is a directional. Kz is a directional coefficient. Kz is the topographic coefficient. KD, directional coefficient, KE, elevation coefficient, and V as the velocity of the pressure. And if it is in Newton meter or IS unit, it is just multiplied by 0.613 instead of 0.0256. This the what is the KZ mean? KZ is a pressure coefficient. KZ is topographic factor. KD wind directional factor. KE ground position factor. V equal to V is the basic pressure. Q is a pressure coefficient. What is basic wind pressure? A basic wind pressure is defined as the 3-second gust speed measured at 33 feet above the ground in exposure C condition. Okay, we will later discuss what is exposure C condition. This wind speed is determined using the historical data and is used to starting point for calculating the design and wind load structure. Okay. So what is the 3-second gust speed? 3-second gust speed is a peak speed that is measured in 3-second interval, which is such as if you consider the first 3-second interval means it is the first. Let's consider that it means the 3-second gust can be calculated by assuming the wind speed measuring at each second interval within the 3-second window and if dividing by the 3. That is, if the wind speed first second is 10 mile per second or meter per second, second is 12 meter per second, and third it is 15 meter per second, then we can sum of this 10, 12, 15 and divided by the 3, that is, it is the 3-second gust. We get 12.3 meter per second speed. This is the basic wind speed, and it is taken from the historical data of the relevant location. Where we get the basic wind speed. That every code has a list or a map okay, wait, I will show you that how you get this is the wind map. So from this wind map, we can this is for the USA only. We can our own wind map. So we can use our own wind map. We can find out what is the wind speed of the location as per location. Okay, we can find the wind speed as per our desired location. And such as this is the wind speed of 107 mile per hour or 48 meter per second. This location is wind speed is 97 mile per hour or 43 meter per second. In such way, we can determine the wind speed of the desired location. Okay, before considering the wind category, wind speed, before determination of the wind speed, we have to learn the risk category of the structure. That is, if the structure is low risk structure, such as a single story dwelling or only normal shed, that is the low risk structure. Risk category 2, the common buildings such as residential, commercial apartment, commercial buildings is this category 2. This category 3, building that pose substantial hazard to human life, such as a chemical building or power plant or hospitals. This is the this type of building considered as risk category 3. Hospital is the risk category 4. So risk category 4 building, that is the facilities for national hospitals, fire station, national emergency building, or cyclone shelter. That is the risk category 4 building. So depending on the building structure, we have to use the subsequent hazard maps of the building. Okay. This is the basic wind speed required for the risk category 2 building. Okay. So if you look at this point, it is 90 mile per hour is for risk category 2. When we use the risk category 3 or 4 building, that it is this wind speed is we increased. Like this is the 95 mile per hour, which is risk category 3. We what we see the before, we see that for risk category 2 building, which is 90 mile per hour, but same place if the building category is in 3, so we have to use 95 mile per hour speed. If the structure is fall into risk category 4, then the speed will be 100 mile per hour. So depending on the structure type, we have to determine the wind velocity depending on the structure type. So if the structure is risk category 2 or 1, it is 90 mile per hour. If it is 3, then it is 95 mile per hour. If it is 4, then it is 100 mile per hour. Okay, what is risk category? The building risk category 1, building and other structures that respect to low risk to the human's life and event of failure. Risk category 2 is all other structures that not fall into 1, 3, and 4. What is 3? Building and other structure that failure, which is food, causes the substantial risk to human lives, that highly explosive storage, fire, fire hazard building, like a chemical building, explosive building. This type of building may fall into the risk category 3. And risk category 4 is the building that considered as a importance, national importance, that gives a national importance, like hospital building, fire station, national radio television stations, etc. This is the fall into the risk category 4 building. So, okay. Beside this, if the building not fall into 1, 3, or 4, it is it is called the risk category 2 building. Okay, then we consider the directional coefficient. We have to calculate the directional coefficient. Directional wind coefficient is a multiplier that used to account the variability of wind pressure in different directions. It is adjust the calculate will not reflect the reduced likelihood that maximum wind pressure will occur simultaneously in all directions. Okay, determination of it. The values of K wind dictionary factor KD from the table. We can calculate the KD. We can find out the KD, value of KD from the table 26.6.1 of the ASCE 702. Here is the table 26.6.1. It main wind force resisting system, we have to consider 0.85. Component and cladding, it is also 0.85. If the charge are stroke, if it is an R stroke, then it is 0.85. If it is circular dome, then chimneys, tanks, or similar structure, it has to be considered as A. Okay, square, if the building is similar to square, it is 0.9. Such as we can directly take this KD value from this table. Now, exposure category. What is exposure category? Exposure refers to the characterization of the building or structure surroundings. That is surrounding trails. That is what is the sorry, which impacts the wind pressure are calculated. That is how if the building is the surroundings of the building location, if it is an urban area, or it is on a seashore, or it is a open or flat land, depending on this rise of this location, we can calculate the exposure category. According to the ASC 7 or 716, we classified this exposure category in three different ways. One is exposure B, exposure C, and velocity pressure exposure coefficient. Another term is velocity pressure coefficient. The velocity pressure coefficient Kz or Ks is critical factor to determine the wind pressure acting on structure as per guideline established in ASC 7. This coefficient is influenced by the exposure category of the site, which is depending on in section 2673. So, what is the Kz or Ka is factor? This factor is also depending on the exposure or category or this category of this building. What we see earlier that wind velocity of a structure is depending on the risk category. Same thing happened here with Kz or K is also depending on the risk category of the building. Okay, gust effect. This is another important factor that multiplied with the full load calculation equation. The gust effect factor is introduced and account for the fluctuating nature of the wind force caused by the gust, which can increase the instantaneous wind loads on the structure. That means if the wind can anytime, any second increase or decrease. So what happened if the wind is continuously increase or decrease on the structure, and this factor will give uh, this constant this instantaneous change of winds structure, loads on the structure, rigid buildings of the structure. The before to get the gas effect factor value G, we have to calculate the building. Is the building is rigid or the building is flexible? Depending on the building frequency, we can call the building is rigid or flexible. Okay, for the building is rigid, for the rigid building, we can use this factor as a 0.85, or we can calculate it from the equation. Okay, when we use the directional procedure, a building that has design windows determined in accordance with this chapter shall comply with the following condition. It does not have any response characteristics that may substitute cross-wind loading, potentially invisibility caused by conflict or flutter, or not have a option with channeling effect or buffering in the buffering way of upwind obstruction warrant special considerations. Okay, sorry for interruption. Okay, the building is demonstrably. That means the buildings has a simple diaphragm of buildings, not it may be no any other irregularities like oriented corner or weak tree or the vertical discontinuity, vertical irregularities, horizontal irregularities. This type of building, without these irregularities, this type of building should be considered as regular shaped building. Okay, and the building does not have response characteristics. Okay. Okay. No special characteristics means such as across the window. Sorry, again. What is the crosswind loading? Crosswind loading when the wind is wind force acting perpendicular to the primary wind direction. If the simultaneously wind force acting perpendicular to the primary wind direction, wind may cause oscillation. So if the wind direction is, let's say, if wind direction is X direction, wind sorry, wind is in the X direction, and if the another wind is came from the Y direction, and this two wind can simultaneously act on a building, it gives a oscillation, gives an oscillation. This type of if not happened, this is not happened, that time we can use the directional procedure. What extremely? This phenomenon where the alternating vortex formed behind the structure. If it is Leo windward force, if there's no vortex occur on the leeward direction, leeward face of the wind building, that if not occurred, then we can use this directional method for this our wind load calculation. This is the this is the vortex condition. This is the vortex tail. If the wind is follow from this direction, and it is the windward direction, and if then no vortex formed in the leeward direction, leeward face of the structure, that time if not occurs, that time we consider we can use the this procedure. This procedure we can use this procedure, but limitation of this directional procedure, it has a limitation. To provide this chapter, take into consideration the load magnification effect caused by the gust in resonance with along with vibration of flexible building. The building that do not meet the requirement in section 17.1.2 or that must have unusual shape or response characteristics shall be designed using recognized literature documenting such wind effect shall be winter procedure. If the building is not is complex shape, it is a resonance with wind vibration, or it has a special characteristic of it is a responsive to wind vortex or lateral oscillation due to the wind load. That time we cannot use this procedure. We have to use the wind tunnel procedure. Okay. Before we go into our example, we, by calculation, if we see that it is less than 16%, 16 pound per feet square, then we have to consider that at least 16 pound per feet square load should be applied on the unit. Less than this, we cannot consider that one. And for the foundation for the roof, it is 8 pound per feet square. So now we should consider how to calculate the wind load based on the ASCE 7063. First, we have to determine the wind is sorry. First, we have to determine the structure type. It is enclosed, closed, or partially enclosed. So in our example, we consider the enclosed building. We consider the enclosed building. Okay, determine the risk category of the building. As per our previous slide, we consider here the risk category of this building is 2. Then we determine the pressure coefficient, determine the pressure. Now calculate the pressure QZ, determine the external pressure coefficient CP or CL, and then for okay. This is the enclosed portion. The issue of the wind which acting on the structure is calculated by this equation. Q is the precipitation coefficient, precipitation that determined from the earlier equation, and this is the equation that act on the structure phase. Structure phase. Q is it? Okay. Why Q is sometimes it is called QZ, sometimes it is QS, sometimes it is QI. What is QZ, QS, QI? It is the QZ is the windward. When wind pressure acting on the windward direction, that is Q should be called as QZ. If it is leeward walls, if it is when Q is in inward leeward side or sidewall side or roof at evaluated height is, that it is called QH. And Q when QI is the windward walls, sidewall walls, leeward walls of roof, enclosed building or negative internal pressure. That time it is for negative internal pressure, it is you considered as a QI. But QI, Q is all are same that we cal- uh, uh, calculated from the previous equation. Q equal to 0.00256 kz, kz, kzt, kd, ke, v square. Here G is the gas factor, GF is the determination, GF is the gas factor for the flexible building. G is the gas factor of flexible, GF is the flexible building gas factor. GC price is internal pressure coefficient. Both Q and QI shall be evaluated using the definition of 2673 pressure shall be applied. And, and if this equation is used for when we consider the parapet, when we consider the parapet of the structure. If we consider parapet above the roof or gables, then we use this. This is the main concept of wind load. How we calculate wind load. When wind is from this direction, this is the windward one. This is the windward direction, and that direction, this is QZ, GCP is the windward force. This is the windward force, and G is the gas factor. This these two are sidewall. This two are sidewall. It is QS GCP. It is also a gas factor. CP is the pressure coefficient, and this is the leeward. Leeward is QH, leeward is QH and GCP. What is QH and QH we said earlier, but QH and QZ is the velocity pressure in respective height. When we consider QZ and when we consider QH, we will discuss later. And one thing to consider here, if the wind is towards the wall, if the wind towards the wall, it is always positive pressure. It's towards the wall, so it is positive wall. It's away from the goes away from the wall. This is the negative. So sidewall pressure always be negative, and leeward plus always negative. It is go away from the this is the cable growth, and this is the okay. How we calculate the internal pressure or wind pressure coefficient? Wind pressure coefficient will depending on the length and breadth ratio. In the direction of wind, it is called B. When it is measured, this length is called B. When the wind flow direction, it is called B, and other direction should be noted as a L. Okay, the wind direction is considered as B, and other direction is considered as L. This is the height. This is the okay. This height. Okay, and this is the A height. And what is being height? Being height is difference between this average of this E height and the this height. What is being profile? If the theta is greater than 10, if the theta is greater than 10, then mean profile should be considered if height plus average of if height and the Lewis height. If it is less than 10, then mean height should be considered as if height. Similarly, same thing here. If it is greater than 3, then the mean height should be this height, and the average of this height and this height. And if it is less than 10, then it is should be considered as this. If the wind is flow this direction, that it should be considered. This is the mean height. If it is less than 10, if wind is flowing through this direction, then it then wind should be this height. Okay. Okay, L by B. If the windward wall, the pressure coefficient, windward coefficient always 8. Pressure coefficient of windward wall is always 8. Pressure coefficient is of windward wall is always considered 8, and it is always gives it. It gives it. Okay. This coefficient always used with this gives it. Remember again the pressure coefficient or windward always used with QZ. And leeward wall, the pressure coefficient for leeward wall is depending on the L by ratio. If L by ratio is 0 to 1 or less than 1, it should be considered as -5. Here, minus means is a negative pressure. Okay, that we call it is away from the 1. So it is always remember the sign. If use this instead of plus sign and minus sign, use plus sign, it will be a catastrophic error. So if maybe it is 0 1, then it is minus 0.5. If it is 2, then minus 0.3, and if it is greater than 0.4, it is 0.2, minus 0.2. And it always used to keep ace. It is always used to keep ace. And remember, we can linear interpolation, it can be used for this use we can use the linear interpolation. If N by B ratio is 1.5, then we interpret point minus 0.5 and 0.3 in between 0.5 and 0.3 value. If it is 1, 2 point, if it is 3, then we use the value in between minus 0.3 and minus 0.2. Sidewall. If sidewall always, sidewall all conditions, sidewall coefficient should always be used at minus 0.7, and it is used with QAs. How do we calculate leeward pressure coefficient? Leeward pressure coefficient is used both H by L and H by B ratio, and angle of the angle of the structure. Angle of the structure means this is the angle of the structure. The structure. Oh, sorry, this is the group pressure coefficient. Group pressure coefficient is determined with H by L ratio. H is the height and L is the length of the structure. But one thing should remember, L may vary if wind is L is when wind is face opposite side. Sorry. What is L? If wind is from this direction, it is called B, and this is the L direction. So wind direction, direction, the length is called L. So H by L means what? If wind is direction will flow from this direction, then L will be this direction. L will be this called L, and then this is called B. So H by L is less than 0.25. H by L is less than 0.25, and theta is 10 degree. 10 degree, then we use -7. If 15, then -5. Here you can see this is a 0. 0. Here we use 0 because for interpolation. Interpolation. It is a interpolation. It is where it is -7 and -18. 1.8. If it is 15, then -0.5 0. If it is 0.3, then -0.3 plus 2.2. If it is 15 minus 2, point and minus 3. And this is the, in this way, we will calculate the uh, root pressure coefficient. If it is greater than 16, then we use 0.01% of the theta. If it's greater than 15, then 1% of theta. If it is near direction, it is one direction, coefficient, root pressure coefficient, and this is the root direction, lower pressure coefficient. It is 0.3. This is the only one. If it is 10 and 0.5, it is only one. So yeah, there is nothing to interpolate. So if it is 12 degree and the ratio is 0.35, then we should interpolate this two value, minus 20 and minus 0.5. Okay. And if it is 15, then this is the minus 0.5, minus 0.5, minus 3. If it's greater than 20, then we want to place minus 0.6. Okay. If the angle is group angle is less than 10 degree, if less than 10 degree and h by l is less than 0.5, then CP is minus 0.9 and minus 0.8. These are two different pressure coefficient. Okay, so we use also to this pressure coefficient. And if the h by l is greater than 1, that time we use minus 1.3 and minus 1.8, minus 1.8 or minus 0.7 and minus 1.8. And this is here the value can be reduced linearly with area over which applied on the flows. That is, if we calculate the greater than 1, we can reduce this value 1.3 by calculating the area, by calculating the area. If area is less than 100 feet square, then we just factor 1. So 1 will be multiplied with 1.3. If it is 250, then we multiplied with 0.9, that is 1. Minus 1.3 into 0.9. If it is greater than 1,000 or equal to, then we multiply this 1.3 value with 0.8. Okay. What is 0 to h by 2? H 2 by h is 2 by 2h. So we'll discuss. Okay, we'll. Wait, I will let it is h. One direction is, that is one direction. Okay. What is 0 to h? It is the move. 0 to h is sorry. Sorry for the writing. It is not looks okay. Okay. And this is the 0 to h. This is h2 by h. This is h2 by h. This is greater than 2h. This is the greater than 2h. 2h, and this is sorry, this is greater than 2h. If so, if it is let it is L, it is let it is 200 feet. 200 feet. So, and it is 20 feet. It is 20 feet. So 0 to h by 2, it is 10 feet. This is 10 feet. This is 10 feet. This is 10 to 10 feet. That is, this is 10. This is 20 feet. And h2 to h, that is, it is 40 feet. 20 to 40, that is, this is 60 feet. This is 60 feet. And it is 2h, greater than 2h to 200 feet. 60 to 200 feet. This is the 2h. And it is h to 6. In this way, we can distribute the pressure on the roof. Okay, and now we how to consider GCPI, internal pressure coefficient. According to the ASCE 16, the internal pressure coefficient can be taken from this table. Okay, internal pressure coefficient from this table. If the building enclosed, it is then it is plus minus 0.18. If it is partially open building, then it is plus minus 0.55. If it is partially open building, what is partially enclosed and partially open? Partially enclosed when partially open and enclosed building are always plus minus 0.18. If it is not partially enclosed building, that is, if total area of the wall is less than or equal greater than is 1.1 of the overall area of the opening area, that time it is called partially enclosed building. If it is does not comply with the partially enclosed building, that it is open building, it is called enclosed partially open building. And partially and open building, in the case of open building, there is no internal pressure, so there is no the coefficient of internal pressure is 0. Now example. Okay, example. Let wind flow from this direction. Sorry, according to this, for this direction. Initially, we consider wind is flows from this direction. This is the length, that is L. If wind is flow from this direction, that is this B, and this is L. That is, this is B, this is B, and this is L. So we take let's consider with wind speed is 115 mile per hour. It is 115 mile per hour. This category, we consider this category is 2. Exposure category, we consider this C, that is flat terrain. The ridge height of this building is ridge height. That is, this is the ridge height. The ridge height of the building is 53.27, and eve height of this building is 20 feet, and length of the building is 200 feet is L, and normal to ridge, that is normal to ridge, perpendicular to ridge, that is perpendicular to ridge is 200 feet, and parallel to ridge, it is 250 feet. And we consider it as a double frame, and we also consider it as a enclosed building. So from the okay, now we consider the gust factor. Topographic factor is taken as a 1. We can take as a 1 topographic factor. Gust factor, we consider this building is rigid, so we gust factor we can take 0.85, or we can calculate from this equation. Okay, we can calculate from this equation, but we in this case we consider 0.85 in both directions. KD is taken from 0.85 KD is taken from 85. Slope of this building is 18.4, and elevation factor is 1. Elevation factor is taken is 1 because it is the overall ground elevation is 0 feet. It is not on a hill or any escarpment. Now we calculate the velocity pressure. Calculate from the velocity pressure, KZT is 0.00256 because we are considering FPS unit. So KZ we calculate later. KZT is 1, KD is 0.85, KE is 1, and 115 square feet is a mile per hour. So KZ is, we found the KZ is 8.8 pound per square feet into KZ. How we calculate the KZ? KZ is calculated from this equation, from this table. KZ is calculated from this table or this equation. Since this is a exposure category C, so you can see 0 to 15 feet. From 0 to 15 feet, it is 0.85, then 20, it is 0.9. If eve height 30 feet, this is 30 feet, 0.98. The main roof height we already said main roof height if theta is greater than if theta is greater than 10 degree, then eve height and average of eve and this height taken is called is mean roof height. So mean roof height is 36.7 feet. 36.7 feet means it is in between 30 and 40 feet. That is 1.98 to 105. We can interpolate. We can linearly interpolate. Take this value in between 0.98 to 1.04. That is 1.02. Then 40 feet, we take this value 40 feet, 56, and the ridge height is 53.27. So we take this value in between 50 feet and this 60 feet. Okay, this is the QZ. Okay, this is and now multiplying this KZ factor with this 22.8, we can calculate these values. That is if 28.8 into 0.85, then we get 34.46. I will show you later this calculation, how to can this calculation. I will show you later, but I also just give you an example on this slide. Okay, now in this way we can calculate QZ. One thing, always remember one thing: if the what is Q, this is the QZ. When this factor is always multiplied with what CP. CP windward direction, CP with windward, and this is the QS. What is QS? QS is nothing, but it is taken QZ of mean roof height. Okay, mean roof height Q is taken as a QS. Mean roof height QZ is taken as a QS. Okay, QZ of mean roof height is defined as a QS, and this is it is also QZ. Simultaneously, it is also QZ. Okay, this is the where wind is this is the ridge line. This is the ridge line. You see the wind parallel to perpendicular to wind direction. It is called L. So L, and this is B, and if wind is normal to the ridge, when wind is normal to the ridge, then L will be this, and L will be B, and B will be L. So if the if parallel to this, the L by B ratio is 1.25, and H by L ratio is 1.47, and normal to this, it is L by B ratio is 0.8, and H by L ratio is 0.183, and angle is slope is 18.4 degree. So how and now from this value, from this three value, we will find out the value CP value. Okay. So windward direction for all surface L by B, for all L by B and all H by L, CP is always 0.8 windward wall, and sidewall wall is always -7. And now it is leeward wall. leeward wall. Okay, now leeward wall is by L. If L by, depending on the L by B, it is not H by L, but I considered here L by A for the other reason. Uh, for L by B is 0.8, that is, it is less than 1. 0 to, it is lies between 1 and 0 to 1, so it is 0.5, it is minus 0.5. And when parallel to this, the L by B ratio is 1.25. That is, it is lies between 1 and 2. So if you interpolate minus 0.5 and minus 0.2, we'll get minus 0.45. And now, root pressure coefficient. Now calculate the root pressure coefficient. The root pressure coefficient is by L ratio. Normal to this is 1.18, and normal to 0.18. That time the root pressure coefficient is H by L is less than 0.25. So, and the angle is 18.4. So 18.4, that means it is lies between 15 and 20. Okay, so 15 and 20, it is 5 minus 0.5 and minus 0.3, minus 0.5 minus 0.3, and this, there is another plus 2. Sorry, it is plus 2, plus 2, and this is the 0. Yeah, here 0 is used for linear interpolation. Okay, so Windward coefficient we get uh, 0.5 in between 0.5 and 0.3, minus 0.5 and 0.3. If we linear interpolate, then we get 0.36, and 0 to 0 to 0.2, we get plus 0.14. Okay, and for 15 to 20, this is a 15 to 20, we minus 0.5 to 0.6, we get the leeward pressure coefficient is 0.57. This is the normal to this. When going for normal to this, that is, this is the wind direction, and this is the this line. So when normal to this, that is the windward. This is the windward roof, and this is the leeward roof. And windward roof, it is a this coefficient is 0.36 minus 0.36 and 0.14, and for leeward whole the leeward roof, it is a minus 0.57. Now, if parallel to this, wind is parallel to this, that is 1.47. This is parallel to this. That is, wind directional is 0. If here H by L is 0.145, and angle, though it is angle 18.4, we can see that if it is gable frame, if it is normal to this, if it is normal to this for, and it is 10 degree and parallel to this, it is all case of 30. If the wind is, okay, go to the next slide. Okay, okay, wind, if the wind is normal to this and slope is 20, less than 20. If wind is slow, normal to this, and slope is less than 10 degree, less than 10 degree, and then we consider this value. We consider this CP value, not for windward direction. For windward direction, we use this value uh, for slope less than 10 degrees. Okay, for slope 10 degrees. But if it is in all case for parallel to this, if for all case, if it is wind flow parallel to this, for all case we use this value for windward or leeward direction, even for windward direction. So what is say 0 to h by 2, that is, remember one thing, when wind parallel to this, there is no window leeward direction. Okay, roof leeward direction, there is no roof leeward direction. So 0 to h, this is the 0 to h, and this is the actually 0 to ace, 0 to ace, 0 to ace, minus 0.9, minus 0.18, and then ace to ace, ace to ace, this is minus 0.5, minus 0.18, and greater than 2 ace, this is the greater than 2 ace, is considered 0.3, minus 0.3, minus 0.18. So we calculate all the pressure coefficient from the table and for this calculation. Now internal pressure coefficient. Since this is the enclosed building, so from this table we consider plus minus 0.18. Now net pressure from this equation. Now net pressure from this equation is okay. Here is QZ. If you remember, wait, in this way we can calculate the wind pressure coefficient from this. Okay, let make it short. We will calculate this wind pressure. This is the once we take the plus DCP, that is positive internal pressure, and then take the negative internal pressure coefficient, and this is the positive internal pressure coefficient, and we can calculate the windward wall. This is the windward wall, this is the sidewall wall, and this is the roof pressure according to this equation. How to apply? Sorry. This is the how to apply. Apply when the wind is normal to this, that is the wind force pressure. 12 point, this calculation 0 to 15, 0 to 15, 11, 12.3. If so, it is a 12.3, and 0 to 15 feet, up to 0 to 15 feet, it is 11.4 meter feet pound per feet square, and 15 to 20 feet, it is 12.3 psl. So if the this member, if the column is spaced between base spacing is 20 feet, plate column is spacing from 20 feet apart. So loads on this column will be 11 point. In this way, load of this column will be 11.2 feet into 20. That is 22.4 pound per feet. In this way, similarly, we can also apply this application of the wind force. This the internal pressure is deducted from this. Both wind pressure is deducted from this 11.4 and 5. This is the deduction. Similarly, parallel to this, we can apply this wind force in this manner. So this is all. This is the wind load calculation as per our ASCE 716, and this is the application of the. I use this for gable frame only. So if you had any question, if you have any question, let me know, or let me know if you have any questions. Have you any question?